It turned out that to estimate probability of A1, A2, AD given Y, we have to make some simplifying assumption. What's this assumption? Is that this is what makes the classifier naive. We're going to make the naive assumption that the feature values are conditionally independent given the label, which means that given the label of the example, the probability of observing the conjunction A1 and A2 and AD, which is a row in the table, so probability of observing this combinations of possible values for each of the features is the product of the probability of the individual features. So where is this coming from? So this is coming from the definition of independence in probability. If you have an event A and B, the probability of an event A and an event B, and assume A and B are independent, then the probability of the conjunction is simply the product of the probabilities, right? So if we have P of A and B, given some condition Y, this would be probability of A given Y times the probability of B given Y, right? Applying this concept into this formula here, we have the probability of observing the value A1 and the value A2 and the value AD given Y is the product, this sign stands for the product, is the probability over all possible feature values of each individual feature value given the Y. All right, so this will make things much easier. Instead of calculating P of A1, A2, we are just going to do P of A1 given Y times P of A2 given Y times, etc., P of A D given Y, right? And each of these values is actually easier to estimate from the data without having a huge data set, because it's likely that A1 happens, but it's less likely that A1 and A2 and AD happen. So we don't have to really focus on having a large sample in which A1, AD appears enough in order to estimate the probability. Okay, got it? So given this, the naive Bayes classifier is simply written as, if you want to calculate the label of the new example, we're going to see which Y in the possible labels that maximizes what. So we have this term, which is probability of A1 AD given Y. We multiply this by P of Y based on the previous, based on this formula here. Okay? So now, can we estimate these two terms from the training data? Yes, just as I said now, P of Y is just count the frequency of P of Y for each of the possible values of labels. P of AJ given Y, we could simply calculate if we have Y, AJ appearing enough, we could estimate the probability of the feature value is equal to AJ, given that the Y, we observe the label Y. All right, the algorithm is pretty simple. All what you need to do is, given a data set, estimate all P of Y's for all possible labels, right? Estimate all conditional probability for each single feature value given the Y. So for all Y, for all AI, so you have AI, all possible values for all feature values. And the classification is done by using the formula that we just saw to calculate the label Y new as the label that maximizes the probability of Y times product of the probability of each individual value given the Y. All right, so we did it. This is how we derive the naive Bayes classifier and how we make a classification of a new instance. So here you can observe that there is no model per se, there is no hyperplane, there is no decision boundary. We just need, given a large sample of data or a data set, which is kind of a snapshot of reality, and we hope that this snapshot is big enough to estimate the probabilities. Just count the frequencies of various data combinations within the training examples to estimate these probabilities, P of Y, P of each value given Y, and plug that into this formula to make a prediction. Okay, so here's an example. So we call this example of hiring different applicants. Suppose we have again this 4 features: highest degree, work experience, favorite language, programming language, needs work visa, and we have some historical data that tells whether the company has hired this applicant or not, right? So we have this data set, and this data set is supposed to be very large. We want to use it to be able to predict the class of a new, this would be our X new, of a new instance X new. So given that this applicant has a master's degree, has this kind of work experience, is familiar with Java, and it is his favorite language, does need a work visa, are we going to hire this applicant or not? Okay, can we predict this class? So let's use naive Bayes classifier to do so. So I'm going to use the formula we just derived in order to calculate what would be the label y for this new instance x new. Okay. So recall we had the general formula is y new is equal to argmax of what? Of values of y that actually maximizes the value, the estimation probability of y times the product over all the features of probability of the value aj given y. Right? So in our case, we have the y belonging to either yes or no, the applicant is hired or not. P of y would be the probability of yes, which would be we just count the frequency of the number of applicants that were hired versus the number of applicants that were not hired, right? The probability of times probability of the different values given the label y. Okay, so in this case, the different values would be for highest degree is masters given the y, times probability of UX design given the y, times the probability of favorite language is Java given the y. So I didn't write the whole feature equal value, times probability of needing a visa is true given y. Okay, so as I said, these two values can be estimated from the table. We have 8 cases over 14 that were of applicants that were hired, and we have 6 applicants over 14 that were not hired. So we need to calculate conditional probabilities for each possible values. So in this case, we are going to calculate the probability of a master's given a yes, the probability of UX design given a yes, etc. So for each value aj, we are going to calculate its probability given the label yes or the label no. So likewise, we are going to do it for the label no, P of masters given no. So by counting the probabilities in the data, so for example, the probability of masters given a yes, if we go back to the data, is 4 over 8. This is because we have, if you focus on only hires is equal to yes, so we have you have 8 hires, right? Among these 8 hires, we have 1, 2, and 3 and 4 masters among those. So this is the conditional probability of having masters given that the applicant was hired. All right, so given these values, we are going to plug these numbers for the case where we have the higher is yes and the higher is no. So we are going to just change the y here in this formula by yes or no and plug in the conditional probabilities to get finally get these 2 numbers that actually suggest that we should hire this applicant. All right? So just to summarize, this is how naive Bayes classifier work. Calculate all probabilities for each possible feature value given the labels that you have, yes or no in this case, and plug in these numbers into the formula for the 2 classes, right? So we have this first formula models the probability of yes, this second formula models the probability of no, and get the y actually that maximizes this probability. And it happened that for the label equal yes, we have the highest probability when you use this formulation. Okay, so a final observation here is that it could happen that a value has a very low probability close to 0. For example, if you have a very large sample, the probability of observing a specific value could be 0, which would have the undesired effect of putting all this formulation here possibly to 0. So if any of them is 0, the whole product will end up being 0. So there is a trick to avoid this kind of situation, and this trick is to just change the estimation of the conditional probability of aj given y. So this trick is called the M estimate of the probability that estimates the probability of the conditional probability of observing the value aj given y using a different formulation. So usually what we do is to, given that suppose that NC is the total number of examples for which the class is y and the feature value xj is aj. And ny is actually the total number of examples for which the class is y. So usually what we do is just nc divided by ny, the number of times we have aj among the y's, right? Okay, so now we're going to use artificially some extension of both values by imagining that there is some extra samples. So the trick here intuitively means that augment the sample size by m virtual examples distributed according to some prior p, prior estimate of each of the values. If the prior is unknown, just use the probability of 1 divided by k, which means that all possible values are equiprobable. So this will have as effect to avoid that this probability ever get 0. Okay, so this is just an artificial way to change the probability estimation of the conditional probabilities in order to avoid getting the 0 in the formulation. Okay, so as I said, naive Bayes classifier is widely used in text classification. Why is that? Because learning which articles are of interest on the web is done by classification. How to classify web pages by topic, how to classify your emails as a spam or non-spam, actually uses a lot the principle of naive Bayes classifier, in which actually case naive Bayes classifier happen to be one of the most effective algorithms to filter your emails. A question is, what attributes should we use to represent text documents? So the intuition behind it is that we are going to augment the sample size by n virtual examples distributed according to some prior p, which is a prior estimate of each value. If prior isn't known, we can assume a uniform prior, which means that all feature values has k values, and we can set the probability to 1 over k, right? So the idea is that avoid having the probability of observing the value aj given y is 0 by augmenting by some values with this, using this m virtual example. Just giving you an intuition that we could go around the constraint of some probabilities being 0 by adding some values to the probability, conditional probability of aj given y. So as I said before, naive Bayes classifier is widely used in text classification. So why do we want to classify text to begin with? Yes, we want to classify it because we want to know which news articles to read. We want to know how to classify web pages by topic. We also want to know which our emails are spam from non-spam. We don't want to see the spam in our inbox. So we are going to deploy some methods that allow us to filter those for us. And as I said, naive Bayes is one of among the most effective algorithms for spam filtering. A question is, what kind of attributes shall we use to represent text documents? So we have seen in the previous example, we had well-behaved data with feature, values, and label. So how about documents? How can we represent these documents? What are the features that we can use in order to use something like naive Bayes classifier? So here again, because of the risk that the probability of a word is given some class is 0, we're going to use the M estimate of the probabilities. The probability of a word WK given CJ is estimated by this formula here, in which NJ represents the total number of words positions in all training examples of the class CJ, and AK is the number of times the word WK is found among those NJ word positions. Okay, so I'm going just in this case to use this formulation in which we add 1 to NK, and we simply add the size of the vocabulary or the number of words in the documents to NJ. All right, so the following functions lends the probability PWK given CJ, describing the probability that a randomly drawn word from a document with class CJ is the English word WK. It also learns the class priors P of CJ. All right, this is a way to do, so this is just to give you a flavor of how naive Bayes could be used for text documents. All right, so just to summarize, naive Bayes is a very useful technique to classify data, as we have seen for the example of hiring. It could also classify text very well. It's actually a linear classifier, and it's incredibly simple and easy to implement, but works wonderfully for text such as spam filtering. So that's it for naive Bayes classifier. See you next time for another topic.